Okay, then we'll just have the panelists on stage first. I know you've heard a lot about VMs these days. People just talk about which VM is better when you see on Twitter and you will see a lot of debates. But we have that people on stage today. I'm sure you guys are all excited to meet them. So next panel I want to introduce Rushi. He's kind of running a little bit of late, but Rushi from Movement, Terry from Eclipse, Keone from Monad, Martinet from Circuit, and Hee-chang from Four Pillars as the moderators. They're going to talk about the end game of VM in crypto. Please give them a warm round of applause.
Hey, great to have you all here. And I think this panel discussion will be really helpful to developers who are building in crypto. So title for this panel discussion would be the end game of VM in crypto. So when we look into the past, there were a lot of dominance of EVM, and most of the developers develop using Solidity. But this kind of landscape is quite changing, and this kind of change was really apparent this year, as there were a lot of SVM builders, MoveVM builders, and there are a lot of projects that are trying to improve EVM. So for these panelists, we really have the top leaders in this space, and I'll try to categorize into aspects. First group will be about teams that are trying to improve EVM, and then the latter would be about providing the alternative of the EVM. So firstly, we have Keone from Mona. So I was kind of curious, what kind of drawbacks did you see in EVM, and how did Mona improve that?
Yeah, nice to be here today. Keone from Monad. We're basically rebuilding the EVM from scratch, and more generally Ethereum from scratch. Both from scratch execution system, a from scratch database for storing Ethereum Merkle tree data, and building high performance consensus from scratch as well. So to your question about sort of limitations within EVM or just the general context of where we are right now, there's just some obvious things to point out. The EVM is just a bytecode standard. There's, I think, something like 50-ish opcodes, and the opcodes generally doing things like add, multiply, store to store some piece of data, sload to pull it back from disk. And it's a fully expressive opcode language. There's nothing really fundamentally wrong with it. There are some quirks, like the size of each storage slot is quite large at 256 bits or 32 bytes. So if you're storing a small piece of data like a Boolean, you still use up 256 bits. But other than that, it's fundamentally fine. And the biggest bottleneck actually for Ethereum execution is state access, because state generally lives on SSD, and retrieving data from SSD is a minimum of 40 to 100 microseconds each time that you have to traverse to the SSD. So without getting too verbose, because I realize I could ramble on for a while, potentially, Monad is addressing this by building a completely new database. But in addition to that, there's a lot of other improvements like parallel execution, just-in-time compilation, and so on that we could talk about a little bit later if you're interested.
Yeah, I think it'll be interesting to talk a little more about Monad DB. I think that is one of the major developments in the Monad ecosystem infrastructure. So yeah, we'd love to hear more about Monad DB.
Sure. So the Ethereum Merkle tree is the Merkle Patricia tree is how Ethereum stores all of its state. So literally every account balance, literally every piece of state associated with any smart contract, it's all stored inside a single tree. And this tree has the property that parent nodes contain the hashes of all their children. So there's this successive hashing mechanism all the way up to the root of the tree. And the root of this Merkle tree is basically a commitment to all of that state. And that's pretty useful because it means that, for example, if Terry and I are both running Ethereum nodes, and we want to make sure that we have all the same state, we can literally just compare Merkle roots. So it's very fast to compare those. And that's really useful for bridging. It's really useful for just more generally interacting with the blockchain. But the downside is that maintaining this tree storage structure is pretty expensive because all the roots have to be constantly recomputed. And then in addition, this data structure in most Ethereum clients is embedded inside of another database like LevelDB in the case of Geth, or MDBX in the case of Reth. And that other database is actually using another tree storage structure under the hood. So what ends up happening is when looking up data inside of a Merkle tree, when navigating, say, from the root all the way down to one of the specific nodes, each node traversal triggers a lookup into this other underlying tree, which just creates a ton of indirection. So MonadDB is a from-scratch database implementation that natively stores this Merkle tree on disk. So it's managing all of the logistics of exactly where data is stored, how the paging works. There's support for asynchronous I/O. The MonadDB also bypasses the file system. So there's all these optimizations to make looking up data in this tree really fast.
A little more question on Monad, like kind of moving a little away from the technical perspective. What kind of like developer experience would be different in Monad compared to other EVM developers?
Yeah, so I'll talk about Monad, and then I also want to pivot this to talk more generally about the benefits of building in the EVM and building in the Ethereum ecosystem. So Monad in particular is a fully Ethereum compatible blockchain. So I think of it as like a puzzle piece that has exactly the same shape as Ethereum. So that means that you could take any smart contract that was built for Ethereum and redeploy it on Monad without any changes. And in the same way, all third-party infrastructure like Etherscan or Phantom Wallet, MetaMask, like just works the same way because the Ethereum RPC spec is the same. So from a developer perspective, there should be no change. Like you could test against Sepolia, you can test against Foundry, like there are not any changes, and that's important because we want common standards so the developers they're not locked into a single ecosystem. Like they have maximum portability and maximum future proofing. I think that's really, really important for any developer that's committing a whole bunch of time to writing really robust code, having it audited. Like you want to make sure that your code is future-proof, and by building in an environment where all of the standards are the same, you really benefit from that future-proofing.
Yep, thanks for the insights. And moving focus more to other projects, like to Zirkit. Zirkit is currently building an AI-enabled sequencer, which is making kind of more secure sequencing and on filtering. So we'd love to learn more about Zirkit, and yeah.
Yeah, so hello everyone. I'm Martinet, Head of Developer Relations at Zirkit. So kind of a quick intro about Zirkit itself. As you mentioned, we're mainly focusing on security at the sequencer level. And so we use basically the same EVM. And at the sequencer, we come from a security background. What we're seeing a lot is in the ecosystem, when hackers trying to hack a protocol, then it gets through and we see the tweets like, X protocol, you might want to take a look at this transaction because you just got hacked for like 30 millions, right? We don't like that experience, and we kind of want to have, since it is a layer 2, this is very different from Monad, and so with the layer 2, we are able to add like a piece in it, right? Which is saying that, hey, can we detect the transactions and then classify it as potentially malicious or not? Kind of, I would think of it as an antivirus on the layer 2. So when hackers trying to execute a malicious transaction, the AI model or machine learning model basically, they will classify as potentially malicious, we put it into a quarantine zone, and so that it notifies the projects, etc. Then projects have the time to inspect, pause the protocol, and users may have the time to withdraw, etc. So that prevents the losses in general. So that's kind of like TLDR.
Great. So were there any modifications in the virtual machine level, EVM level, or like will that architecture be compatible with other maybe SPM or MoveVM?
Yeah, so interestingly, we do not need to touch the EVM level. I kind of like, as you echoing, as he said, like it's just a standard and we can maintain untouched. And then we are mostly improving on the ZK proof side. So we're a zero knowledge layer 2. And so we're improving on the zero knowledge side so that to make that, the EVM part, the proof part, much more compact and efficient. And I would say that's kind of like the focus of our work. The EVM side itself, not necessarily. And so most of the work are on the circuit side.
Yep, thanks for the insights. And moving back a little bit to the VM level. Oh, great to have you here, Rush. So yeah, maybe question to Terry from Eclipse. Like Eclipse is currently building a L2 in Ethereum.
A network extension.
Okay.
Is it L2 or network extension? What do you guys?
A network extension.
Are you actually gonna call it?
Oh, you guys
We're in L2. We're in L2.
you guys abandoned L2?
Yeah, we're in L2.
Let's give him a side chain.
So yeah, we'd love to hear about what you guys are building and what kind of benefits are there in the SPM.
When you think about a VM, I think there's two components that are important. Number one is performance, right? The EVM already has a huge amount of network effects. It has Foundry, it has Forge, it has Alloy, it has all these interesting dev tools and a plethora of choices that you can choose from that allow you to develop applications quicker and that people are used to. So it has network effects. So if you're going to adopt a new VM, what do you want out of that, right? I think you should get performance. I think you should get some sort of other desirability. Perhaps it's safety from formal verification. Perhaps it's direct support for local fee markets, as well as maybe other elements that are better for dApps, better for users. I think that's number one. I think number two, and as per what Keone mentioned, what's important in a VM is network effects around the execution environment and building on that execution environment. And this is why the EVM has been quite dominant to date, right? Because the EVM has this rich ecosystem of developer tooling, right? Even if you think about smart contract development frameworks, you can trace 4 generations of iterations from like Ganache to Foundry with different types of vendors and different types of choices that people can make. And this is very, very important. This is where I argue the SVM is a big up-and-comer in this area, right? The SVM has obviously demonstrated in terms of in production performance that it is quite dominant. But in terms of network effects, the SVM is also coming up. Anchor, but other like developer tooling, developer ecosystem, as well as different dApps and frameworks that you can use to create interesting SVM applications. So in terms of what Eclipse is building, that I think is interesting. Ethereum exists as an L1. There are many L2s that are settling to Ethereum and or adjacent to Ethereum that are EVM L2s and or Stylus just launched yesterday, WASM VM L2s. What's interesting about Eclipse is that it's bringing this entirely new functionality and expressive language and entirely new ecosystem that is Solana, which is in itself a very rich, very large ecosystem, onto Ethereum.
Yeah, so you guys are like kind of more bringing Solana developers, Solana dApps to Eclipse. So is that currently a main goal?
For now, we see 2 large inbounds. So number one, we see a lot of Ethereum developers that are like, okay, this is an Ethereum L2, and so therefore we are interested in exploring. And they've contacted us saying, hey, can you connect us with like, some developers or maybe a developer shop that can then help us bring our Ethereum contracts onto the SVM. So we've seen quite a lot of those people. And then the other part is, yes, we've had Orca launch Solend, Mango. We've seen core SVM developers that are coming onto Eclipse as kind of like a means to branch out onto Ethereum. So it's kind of like Ethereum developers that want to try out Solana, but it's on Ethereum, and then Solana developers that want to try out Ethereum because it's on Ethereum.
So I think like most of the developers here will be EVM developers. So if they want to deploy an Eclipse, like what is the kind of the process? Like if they ask if there's a SPM developers out there, did you guys like connect with the developers out there, or do you have any like team that specializes on that?
Yeah, we're connected with quite a lot of teams that are interested in helping people port over their EVM contracts to the SVM. And so if you guys are an EVM developer and you're generally interested in being on Solana, not necessarily even being on Eclipse, but being on Solana, please contact us and we can put you in touch with people that might be able to help you out.
Thanks. Yeah, moving on to Rush. Movement Launch is really building interesting things, and the Move ecosystem is really quite fragmented. The Aptos Move is different, Sui Move is different, and the community is kind of like really dispersed a lot. So are you guys like trying to build with the Aptos move, and what kind of like strategies are you taking?
So we support both styles of move. The Aptos move or the DM style, which is the original Facebook's programming language, is the canonical version. So ultimately, they're the same bytecode. They just have different like semantics. You can think of it like React and Vue for JavaScript. But our canonical VM is Aptos move VM. Like most of the ecosystem is Aptos. I think we have like 3 Sui move projects, but I would say majority of the focus is on the Aptos move or DM style.
Also, I kind of want to learn more about like what are the real benefits of using Move and developing a dApp with it.
Yeah, I think Terry went into the benefits of like high performance execution. I think we're all on the panel trying to talk about that. I think I'll uniquely focus on security aspect. Every year there's $4.5 billion lost in smart contract hacks. If we ever get to a point where we want to have real capital on chain where people can feel comfortable, there's over $1 billion now of TVL on Move, and there's been 0 hacks to date, knock on wood. So I think what's been really shown is that formal verification runtime is really important. Having secure integer types and memory types is very important. And having formal verification runtime enables you to go 0 to 1. So if you're a newer developer, it's really difficult to write really good Ethereum code. Making sure that re-entry is gone, making sure that integers aren't overflowing. For a new developer, it's kind of difficult, and that's why we see hacks across the board. Even like Curve, Kyber, the DAO, these are all major blue chip protocols that all get hacked. So what Move allows you to do is go write very secure code without needing a PhD, without needing spend months debugging and tens of thousands of dollars auditing. You can write very, very secure code pretty natively. And that's what we've seen so far in the Movie system. We have new developers. These are like young developers that haven't touched crypto before. They're able to pick up a new language like Move, deploy in a mainnet, and get product feedback in weeks instead of waiting months, potentially years on the EVM.
May I
Yeah,
kind of want to add it to it a little bit because my background, used to be a security auditor. I also studied a little bit of Move as well. But overall, from my experience as a security auditor, most of the issues from the, while an ecosystem starts to be more and more sophisticated, most of the hacks actually come from the business logic errors. Instead of the type, like in the beginning of Solidity, there's a lot of like, overflow, underflow, those kind of like language level thing. However, once it gets over, kind of the ecosystem become good, etc., it's more become like business logic. And so I think in the beginning, when the ecosystem is not as familiar with the programming language, it's really helpful. But on the higher level, on all the hacks, I wouldn't say that covers all of that.
It does cover it. Like there's flash loans, there's like price oracle like manipulations. Those are big amount of hacks, and no ways Move perfectly. It's not like the godsend, right? Yeah. It just generally is secure, safe programming, solving a lot of the like annoying issues. Obviously, you have a lot of business logic issues that cause a good amount of the chunk, and you want to work on improving that. But that's not really human error per se. That's also just like if a hacker actually manipulates. What I'm referring to is like, if I'm a new developer joining crypto, there's a lot of like arithmetic taking account. There's a lot of small nuances that end up being big deals. Like look at Kyber attack. That was like an integer overflow, and that's Kyber swaps, one of the biggest blue chip DeFi protocols. It was like a 0.00. It was like one line of code that one of their devs pushed. It was like line 174, and that one line of code lost $50 million overnight. So yes, it's a smaller like. The human error is still one subset, but it's a pretty big subset. And like if you look at most of the blue chip hacks, it's usually one of those.
Wait, so I don't know much about Move, but do you just get like a compile time error if you try to push something that can cause integer overflow?
You just can't compile it because like each module will check for like resource type memory safety. So let's say for example, running Solidity and there's like integer overflow or whatever, that gets compiled at runtime unless you have some kind of block set from the compilers. But usually if you deploy on ETH-L1 right now, there's nothing stopping you. And that's why so many exploits happen. In Move, it doesn't compile. They'll like throw a flag up.
So yeah, I was also curious, like, were there like major like hack events or major like vulnerabilities that Move had in the past?
Any hacks?
Yeah.
There's been 0 hacks on Move to date.
So when you guys like launch Layer 2, will there be more focus on the DeFi aspect or other like applications?
I think there's, you're saying like the use cases what we're focused on?
On the
Yeah, I think the go-to-market is like, look, there's two sides of the thing. There's obviously high throughput execution, fully on-chain apps that able to do 100,000 like TPS numbers that we all fight over. But I think the unique angle is like, look, if you want to put capital on chain that doesn't want to get hacked, it creates this flywheel effect where if you have capital that is secure, people are like, oh wow, I'm not getting hacked there. Let me put more capital and be more trust aligned there. So security is actually really important. It just like it's not really a narrative because it's not been security coins that have pumped, unfortunately. But it's pretty important in terms of having retail consumer confidence as well as like institutional LP confidence. Like if I'm coming and tokenizing a fund on chain, moving funds between like Aave, I want to trust that smart contracts aren't going to get hacked. Because if I lose millions of dollars, that's a lot of consumer confidence gone. So I'd say we're all up here trying to focus on high throughput execution, and that's also one big use case. But I think we're uniquely focused on the security aspect as well.
Yes, and putting more focus on the future, like maybe 1 year or 5 years later, do you still see the dominance of EVM, or do you see there will be a lot of like diverse VMs competing each other?
So the monthly developer count for Move is 7.5%. It was double from last year. I think our goal and what we're trying to push towards is 20% by next year. So I think EVM and SVM will change like 40% each. And then the third kind of language will be Move. So I think it's like 40% EVM, 40% SVM, and then 20% Move. And yeah, that's kind of my vision. It's ambitious, but my vision.
I would like to
Keone may not
hear.
agree, though.
I'm also curious. Keone's thought on this.
Well, I mean, I think everyone is going to say what, we're all biased, but
Yeah.
I think that everything's also very path dependent, and I think it's true that, at the moment, Solana is a real, uniquely performant environment in a lot of developers' minds, but that can change overnight. So it's just dependent on the introduction of new technology.
Yep.
Terry, do you have any opinion on this?
I agree with what Keone said.
Yeah, just like markets dictate developer count and developer interest. But I think my thesis is all three will coexist. You will have EVM exist, you'll have Solana VM exist, and you have Move exist. I think my analogy is like you have PHP, JavaScript, and there's like two variations of JavaScript, like React and Vue. So like Rust-based programming is like JavaScript, and you have like React and Vue, which are two frameworks like Move and Anchor. And today on Web 2, you're writing PHP, you're writing React, writing JavaScript. They all coexist. Some of the biggest apps are all written on them. So it's up to developer choice.
And also there's like a lot of like alternative VMs out there. So maybe not in this panel. There are like WASM VMs and also like ZK VMs that are just general RISC-V based. Yeah, do you have any thoughts on the future of theirs kind of as purchase?
I might insult someone here, so I'm trying to serve the crowd. I don't understand ZK VMs really well. I don't see the benefit. Like if you use any ZK L2 versus Optimus L2, the user experience is kind of the same. Yes, withdrawal times are better, but like Base still is cheaper than every ZK L2. I think Base still does most amount of volume on all L2s. So I don't per se. I do say like eventually the future is ZK and like eventually we can get there, but I don't think it's like a groundbreaking UX. And I think the market's kind of proved that. I can't name one app on any ZK VM. I don't know if you guys can, but that's my take.
But there's also, right now there's no fraud proofs on Base.
Yeah, I fully agree. But
So,
if people use L2s, you're probably using Base. I fully agree. And Arbitrum obviously is fraud proofs, but my point is ZK versus optimistic. I don't see the merit in ZK VMs. Even though eventually that might be the direction, today I don't see the merit.
Yeah, I think it just needs time to kind of like do the research and then go there. Like you need someone that, to not just rely on the optimistic route and then we improve there. So we do need to go kind of like on that route. But I think there's also two things. Like there's ZK EVM and then there's ZK VM.
Yeah.
Right? And there's the more general ZK VM. I think ZK VM is also kind of interesting, not just like the general, not the specific EVM for the rollup part, because ZK VM, I've seen lots of like interesting tools so that, allows developers to craft very specific, just like the proof system for, for their specific application and do not need like the whole EVM, and that becomes like much more efficient. And I think those are pretty interesting to see. So I would kind of expect if those framework takes off, kind of like really app specific.
I think ZK VMs make sense because you can generate fraud proofs from that. But ZK EVMs is actually today is a poor user experience compared to optimistic. I use like Arbitrum. I think over time ZK is going to get cheaper, and then that's when it'll change. But today and tomorrow, I don't see that.
Right now, it's.
I don't think it's a user experience issue. It's more like the ZK teams made amazing technology. State diff amortization over like byte cost per transaction makes ZK Sync extremely cheap if you post state diffs instead of full transaction call data. The issue is they just didn't focus also on the go-to-market as heavily enough, right? Which is what you're saying. But frankly, if you just look at the technology, I think state diff ZK EVMs are much more horizontally scalable.
No, they are definitely better. I just think like from a user experience point of view, the jump from optimistic to ZK isn't as big as from like a jump from optimistic to a next-gen VM, like what we're all building. You have fundamentally higher throughput, and you can recognize that today. If you go use like a mainnet version, I'm sure if I use Eclipse, it would be very good performance compared to like an optimistic rollup.
Yeah, so moving back a little bit to the VM, I think we can conclude by one more last question to Keone. So I think there will be a lot of developers here, so if they are building something, what kind of things you would recommend building and where? Like maybe potentially, yeah.
Yeah, I think I saw a tweet today from Chao Wang from Alliance DAO talking about his experience like playing with social apps, like Chinese social apps, and just how addictive and crazy they are compared to like what we're used to in the West. And I just think that, like in the DeFi space, we see like DeFi is really the area where crypto has first found product market fit, especially within payments, but then also within some of the other fundamental primitives, whether that's lending protocols, DEXs, et cetera. But consumer crypto is still so nascent right now, and every consumer crypto app is different. So literally, like, the problem that you see of like there's like 100 different DEXs, literally every single consumer crypto app is inherently different. So I think that would be where I would focus, because it's going to result in more uniquely differentiated product, more uniquely differentiated go-to-market. Apps can coexist. There could be network effects with apps like actually just collaborating. So I think that's really where I'm excited about, especially the space going forward.
So you're bearish DeFi?
I didn't say that. I just said that. I think it would be like if you you were cultivating a new planet, and then we just like spent all of our time building food production, and we didn't spend any time on like, I don't know, entertainment. Yeah.
Yeah, thanks for sharing your thoughts, and yeah, thanks to all the panelists for sharing your opinions. So yeah, it was also great chatting with you.
Makes sense.
Thanks for hosting.
Thank you.
Thank you for having us.
Okay. There were some fun discussions. I hope you guys all enjoyed the panel, and if you guys have any questions about the VMs, how the future is gonna be, like if you have any concerns, ask Rushi, Terry, Keone, Martinet, and Hee-Chang. Yeah, so next up is, we have to talk about security, right? Make security great again. We have Nam from Hyperlane, Amal from Redstone, Ji-Hoon from Babylon, Jason from SolLayer, John Park from A41 as the moderator, but I will be John for today, so come on, panelists, to the stage. Okay, so I'm just gonna set up the timer for 30 minutes, and here we start. Hi everyone, great to see great players like Hyperlane, expanding the modular ecosystem, Babylon, doing risk-taking on the great Bitcoin, Redstone leading the oracles in the new worlds, and like SolLayer from doing the new risk-taking protocol for Solana. Yeah, but I'm sure a lot of people don't really. There are some crowds that are kind of new to this crypto, and I just want to ask you guys to do a short intro of yourselves.
Test. Oh, cool. Hi, everybody. My name is Nam. I'm working on Hyperlane. It's a quick intro to Hyperlane. Hyperlane is an interoperability framework that allows anybody to deploy Hyperlane to get connectivity between arbitrary two chains. We support multiple execution environments, such as the EVM, Cosmos, SVM, launching on Clips very soon. And there's many other people who are building Hyperlane implementations for their execution environments. And so that's kind of a quick 2 cents on that.
Hi, I'm Jun from Babylon. And Babylon is about Bitcoin staking. And what that means is that we're trying to build the third native use case of Bitcoin after store of value and payment. And then here comes staking. So, what we are, where we are positioned is actually not a restaking layer, but just staking layer the first time of its time, and there hasn't been any staking layer on Bitcoin, and we are building that. So we are a little bit different from liquid staking layer and restaking layer. So I just want you to point that out before we discuss further.
Hi, everyone. My name is Amal. I'm a business development partner at Redstone Oracle. We are a modular oracle focused on pricing yield-bearing assets and collateral for lending markets, as well as we specialize in pricing LSTs and LRTs. We're deployed on over 50 chains, and we're trusted by some of the largest lending markets in the space, like Morpho and Venus, as well as the largest LRT players in the space, EtherFi, Renzo. So, yeah, great to be here. Thank you for having me.
Hi everyone, I'm Joshua from the Soul Layer team, and we're building restaking on Solana in a manner that makes the most sense on Solana. So being able to secure both your on-chain dApps as well as your off-chain modular systems or network extensions. So a lot of interesting things coming up the next couple of weeks, and invite everyone to kind of stay tuned as we head into Solana Breakpoint and Token 2049.
Okay, thanks for the introduction. Since we have a lot of, we're talking about a little bit of restaking here. I'm just curious, where do you think we're at the hype? Everyone's talking about restaking, and where are we right now? And how is your team planning this accordingly? Do you want to go first?
Yeah, sure. So in terms of where we are, I think restaking is still very new, and we are exploring a lot of new use cases when it comes to reusing and reusing stake security. And I think each ecosystem is mostly setting into what they feel or what they know is best suited for their chain or their ecosystem. So Babylon making the most sense for Bitcoin, Eigen or Symbiotic being tailored to the Ethereum ecosystem. And for us, definitely on the Solana ecosystem, we'll be implementing things, customizing it to each of our own chains, and exploring new forms of utility. So for us, we're looking at how do you secure network bandwidth directly on the layer 1 itself, mainly because Solana is very heavy on the layer 1 side. Of course, there's going to be a lot more innovation, and we see a lot of teams spinning up layer 2s, rollups, and other kinds of network extensions on top of Solana. And we're also going to be supporting that in the coming weeks. But I think, in the future of restaking, every chain, every ecosystem will find that a good balance between how they work on their own chain.
Yeah, I would echo what Joshua said in the sense that we are very early in the narrative. I mean, as we know, slashing still isn't implemented on EigenLayer. There's still very, very few yield out there. So very early. In terms of us at Redstone, we were the first oracle to begin pricing LRTs. So we're going to continue to do that. For us, our priority is allowing as many of these LSTs and LRTs to integrate into other DeFi protocols so that we can make the cost of security very low. And if people can still use their LRT tokens to borrow against, it makes the cost of securing these AVSs very low by solving the opportunity cost of money. Yeah, very early, excited to see how the space plays out, and we're going to continue setting up the infrastructure for pricing these assets.
I think Bitcoin ecosystem is even earlier than that because there hasn't been no staking layer in Bitcoin, right? So hence there's no liquid staking layer, there's no restaking layer. But since considering the sheer amount of liquidity in Bitcoin, which is about $1.3 trillion, I guess, and that is going to be kind of released through the Babylon starting from the staking, and there are a lot of more than 10 different liquid staking projects on top of Babylon, which will naturally lead to the restaking projects soon rather than later. So I'm very excited to see many interesting restaking projects as well as in Bitcoin ecosystem.
Yeah, I think, I think we're in the same phase like we are more broadly with crypto, which is always too early in the sense that like there's a lot of like stuff that has to be built, right? Like I just mentioned, like slashing is implemented, but even just I think just building the basic staking systems, right? Like I think there's a lot. If you look actually under the hood, a lot of these like systems are not there yet, right? Like basically like most of them you can like deposit the assets into it, and then that's kind of it. And so as a like I guess developer against those staking systems, it's definitely very interesting to see these primitives actually being built so that like somebody like Hyperlane can actually like leverage those, right, for security. But I think at the same time, and I'm curious on your guys' opinion, to be honest. Like I feel like there's so much hype about restaking, but yet like so little like I have seen very few projects that are actually able to like leverage that. And so I'm kind of curious, like from your perspectives, like what is like the most like what do you think is the biggest barrier to actually getting those adopted? Like sure, like we are early and like there's a lot of infrastructure that has to be built, but like what's actually missing to allow developers, aside from that kind of like building, what is missing for developers to actually like leverage that economic security? Because obviously like if they don't do that, then like this is all besides the point.
Do you want to do it once?
So I think I'm not sure if I'm answering to this question, but I think there's a huge imbalance between supply and demand in terms of restaking, and I think this is a overly supply market, right? And demand. We are not sure. I think this is some kind of elephant in the room, right?
Yes.
We all know that that's going to be a huge risk, but nobody is really tackling that. Nobody is really saying that, right? But we do know that there will be some risk.
Yeah.
So I think that's one thing that every developer or every contributor in this risk-taking ecosystem should be aware of, and should be kind of I don't know, have some solution, or I don't know, maybe some mitigation plan to navigate this potential risk.
Yeah.
Yeah, I would say that's the million-dollar question that everyone in the space is trying to answer: how to make it easier for developers and incentivize developers to actually build something that's going to have product market fit, which is actually revenue generating. And frankly, it might be too early to say.
Yeah, I think tackling risk as well as like how do we incentivize developers to build. I think there's a lot of attention on Solana right now, so I think there's a lot of developers who are looking to build. What we help out with is to make that barrier to entry a lot lower, mainly because now developers can bootstrap liquidity, or if they need network throughput, they don't have to bootstrap their entire infrastructure, run validators, point stake towards themselves to accelerate their transactions. That usually only exchanges or large players can actually afford. We're trying to bring that barrier to entry a lot lower, and also make it easier for them to kind of capitalize on the network effects. One thing we have is a shared liquidity layer across all of our AVSs, so that they can actually kind of have like network effects that can support even the smallest builders. So they don't need to fork out like $1 million to kind of build infrastructure. In terms of risk, we're actually going to be implementing a separate kind of risk or slashing mechanism that allows for different tranches so that your user funds aren't being slashed all in one go. I think that's going to be very healthy, and we'll enforce it on the protocol level to make sure that user funds are being protected.
Okay, yeah, we just talked about some developers' experience perspective, and I just also kind of want to tackle the sustainability side of things, and like on you guys, like how much security does an AVS require, you think, and like how would you as an AVS will like cover the cost in terms of like reward, going back to the stakers? Do you guys have any roadmaps on that?
Yeah, ideally the security should be correlated with the total value secured, which is about between 3 and 4 billion right now. The reward rate, it's still too early to say. It's for us at Redstone, it's not decided yet. We'll try to be competitive. I mean, we are actively generating healthy revenue from our customers. So there is a lot of funds that can actively be redistributed to users, and that's something we're actively mapping and seeing how the space evolves to make the final scope.
On our side, I think because we're supporting the dApps themselves on Solana, and mostly there's a lot of dApps that collect fees and are able to generate revenue, so they are able to afford the incentives. And it's also because we are going as a pay-as-you-go model in that sense, where if you're a smaller project, you probably don't need that much network throughput, so you don't need to incentivize staking that much. But if you're a larger project, you might need a lot more transaction throughput, but at the same time, you probably have the revenue to kind of support that kind of expenditure. So it's very much friendly towards both sides of the equation, whether you're a large project or you're a small project. And in terms of the, what's the second question?
How would you, as an AVS, will cover the cost? But I feel like this will be, more relevant to like Hyperlane, I would say.
Yeah, I think we have like Hyperlane currently has an EigenLayer AVS. We're working with various staking providers to provide security from other sources as well. But yeah, I think the $1 million question, I guess, is like, what is actually a sustainable kind of like fee portion of the fees that can go towards these operators, and will restakers kind of like see that to be sufficient, right? Because like right now, obviously, most people stake mostly with an expectation of kind of like very large returns, which are like unlikely to kind of like come join. And so I think the bridging space, I guess, that Hyperlane is in has not yet enjoyed a view on economic security at all, right? Like most bridges are effectively proof of authority bridges, and so we're really like leveraging reputational security over economic security. And so I don't think we know yet like how the market will basically price like economic security comparative to reputational security, and then therefore like how much of economic security do you actually need and therefore need to pay for from these different staking sources. So I think that's definitely like something that's like like super interested in seeing through, and like I think we as Hyperlane are definitely very interested. Like what we're actively building towards right now is like the slashing component to like actually make economic security like not just like a narrative, but like an actual reality. But also again curious to hear, especially maybe from Babylon and Solaya, like how do you guys help, I guess, like let's say your AVSs think about like how much, like what is the cost of that economic security, right? Because like, I think right now there's still very little demand for the economic security, and so it feels to me a little bit like it's basically free. But yeah, curious kind of how you guys thinking of pricing the stake that's available in your platforms.
So in case of Babylon, what's good about Bitcoin staking is that the expected APY from Bitcoin holders is very, very low. Like how many APYs can you expect out of holding or holding Bitcoins? Zero, right? So if you can, as a Bitcoin holder, if you can generate some like 1 or 2% yield out of your Bitcoins, that is going to be a 0 to 1 moment for Bitcoin holders. Meaning that the AVS, normally we just say POS chains or rollups because that's the primary focus for Babylon to provide Bitcoin security. Their security cost can significantly